Okay, so today we're going to learn about how to use trig to find not only missing sides, which is what we did yesterday, but also how to find missing angles. So we have learned if you're looking for a side, you're going to use sine, cosine, or tangent, depending on where your angle theta is and depending on which sides you're given and which sides you are looking for. So I'm going to start by writing SOHCAHTOA at the top of my paper because that's always my reference. I am wanting to find side DE in this right triangle. So I'm going to go ahead and call that X. I know that my angle is 51 degrees. So if I'm using that as my theta, then X would be the opposite side. 18 is across from the 90-degree angle. Here's my right angle. So 18 is definitely my hypotenuse. I'm looking for the opposite side. I'm given the hypotenuse, so I go look at SOHCAHTOA and think which of the three trig functions relates the opposite side to the hypotenuse, and that is sine. So sine of 51 degrees is equal to the opposite side x over the hypotenuse, which is 18. Opposite over hypotenuse. So I have the 18 in my denominator. I'm going to multiply both sides by 18. 18 times sine of 51, making sure that my calculator is in degree mode. 18 times 51 is 13.988. If I want to round that to the nearest tenth, the 8 bumps this 9 up to a 10, and then carry the 1 over, so that rounds up to 14.0. So x equals 14.0. Can double check. Remember, my hypotenuse always has to be the longest side, and the leg that I just found is less than 18. It's less than the hypotenuse, so whew, at least we got that going for us. Okay, so that was when we were given an angle and we set up a equation using a just regular old trig function to find a missing side. Well, when we're going to be looking for a missing angle, we are going to use what's called an inverse trig function. These are my inverse trig functions. And if you notice, they have those little -1 exponent looking things at the top. That -1 you will see over and over again for the rest of your math career to represent an inverse. Basically, it just means going in the opposite direction. So if in the first scenario I knew my angle and I was looking for my side, this is the opposite direction. I know my sides and I'm looking for my angles. So that's why it's called the inverse. It's like the reverse. Instead of me giving you the angle and you finding the side, I'm giving you the sides and you're finding the angle. So if you're ever looking for a missing angle, you are going to use sine inverse, cosine inverse, or tangent inverse. So I want to do the same process. Look at the triangle. Look at what I know. I want to find the measure of angle H. So angle H is my theta. That's the angle that I'm trying to find. So I'm going to determine if sides are opposite, adjacent, or hypotenuse based off of the location of theta, based off of where angle H is. So if I'm looking for angle H, 15 is the opposite side. 17 is across from the right angle. 17 is the hypotenuse. So this is very similar. I know the opposite and the hypotenuse based off this angle. So I'm going to use sine because sine is the trig function that relates opposite and hypotenuse. However, because I'm looking for an angle, I'm not using sine, I'm using sine inverse. I'm using inverse sine. I'm using sine to the little -1. And normally in my parentheses, I would plug the angle. Normally I would plug the angle into the parentheses because that's what I know. I know the angle. I don't know the ratio, hence why I have a variable. So I know the angle. What I know is getting plugged into the parentheses. Well, Here, I don't know the angle. I can't plug my angle measures into the parentheses. But what I do know is the ratio. I know the opposite over the hypotenuse because I have both of those sides. So what I know, what's going to get plugged into the parentheses is the opposite side, 15, over the hypotenuse, 17. That is what I know. And I'm using that to find what I don't know, which is the angle theta. So we'll think back to the original. What I know, the angle got plugged into the parentheses. And what I didn't know was what it was equal to on the right side of the equation. So here, this is the opposite. What I know is getting plugged into the parentheses. I know the ratio. And what I don't know, the angle, the equation. So you might be thinking, where am I going to access my inverse trig functions? If you look at sine, cosine, and tangent, right above them on the calculator, there's sine inverse, cosine inverse, and tangent inverse. So you're going to press the second button and then one of your 3 trig buttons to access the inverse trig function of your calculator. So I am trying to find my angle theta, so I'm going to press second sine. The sign with the little -1 appears. I'm going to put 15 divided by 17 into the parentheses, and I get 61.927 blah 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 blah, so rounded to the nearest tenth. 61.9 degrees is my angle. So the measure of angle H is 61.9 degrees. A couple things to keep in mind. If this is a right triangle, both of these angles are going to need to be acute. So if you end up with an obtuse angle or a right angle for one of your missing angles, you did something wrong. Both of these angles have to be acute. And then another thing, make sure that your angle is positive. Make sure your angle is positive. You might be in radian mode on your calculator if you're getting either obtuse or negative angles. So make sure that you're getting positive acute angles. Okay, so in conclusion, when you are looking for a missing side, you plug what you know, which is the angle. You plug the angle into the parentheses, or theta. Either way, you're plugging the angle into the parentheses, and then that's going to be equal to your ratio. So sine is going to be equal to opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. So you're plugging your angle into the parentheses, and your ratio is on the right side. That's what we don't know. The ratio is what we don't know. Well, when we're looking for a missing angle, that's what we're trying to find. We do not know the angle, so we cannot plug the angle into the parentheses. What we do know is we know the ratio. So we're going to plug the ratio, opposite over hypotenuse, adjacent over hypotenuse, or opposite over adjacent. We're going to plug one of those 2 ratios into the parentheses using an inverse trig, and that will give us that missing angle. So if you notice, the reason these are called inverse trig functions is it's the reverse. Instead of plugging my angles in and getting the ratios, I'm plugging my ratios in and getting the angles.